My name is Dillon Do from Google Cloud, and I'm a technical account manager and lead for one of our largest customers at Google Cloud. My colleague, technical infrastructure lead, Swati, here is with me today to lead the session together. As you may have noticed, the title of our session is When Aspirations Meet Reality. At Google Cloud, we have a variety of large and complex projects going on, and we wanted to share the types of the challenges that we've been experiencing, and also how we've been evolving to make migrations successful, specifically with some of our customers who've been with us close to a year. Throughout their journey, there have been many aspirations around what we wanted to achieve, such as new technology adoptions and products, and we wanted to share what was the reality during the implementation and how we address the roadblocks. We will open our conversation by sharing the approach and examples, then discuss what we learned and apply for our customers. Here's our agenda for today. We'll share the following. First, a high-level view around the customer migration journey at Google Cloud. Second, our migration approach. Third, aspiration versus reality and its rationale. And finally, how we revise our guiding principles to reflect our learnings from the past. After sharing those new guiding principles, we'll open our session for Q&A. So, journey for migration. When you think about the cloud migration journey, it may sound simple, like another migration approach. But there are many factors to consider, including how we are going to discover and identify some of the key workload, how we are going to plan and design and architect the future design, and also plan and design how we're going to deploy those things. When you deploy those workload, how we're going to execute and optimize as we operate the environment. These topics are relevant across technology, organization, and support structure and processes. We understand that it requires a lot of work, and there are many areas for consideration. Lots of late night food and coffee, of course, and staying in the office till midnight or late night, troubleshooting issues and mistakes that we have made in the past, and also improving and supporting what was previously implemented. The third picture in the left is our lead engineer, Jose, in the office, probably around like 4 a.m., troubleshooting the issue with an engineer in Sydney. It appears that this is a very kind of common sight in the migration projects. I think that we ended up probably staying until 6 a.m. to solve the issue. So big shout out for Jose for support. To cover all these topics outlined here, we probably need another whole day to cover that. Instead, today, we will hyper-focus our topics in technology during the plan and deploy phase. This way, we'll be able to share more specific examples for you, which you can apply for your own organizations immediately. So let's talk about some of those high-level approach first before we get into a little more details. We talked about those 4 stages of the customer migration journey in the previous slide. These stages get repeated in each phase of our migration approach. For the migration approach, this is an example of how we view the world of complete cloud migration, beginning from building the foundation layer to migrating the key workload to cloud as a hybrid architecture, and building the full data center capability in GCP, and finally moving data and retiring some of those on-prem data centers. Let's double-click each one of those. Phase 0, this is kind of where we build the core GCP foundational components and validate key assumptions. The goal of this phase is to build the components so that it can be ready for future migration. Phase 1 is where we migrate selected workload and build automations around GCP deployment. This can be considered as a hybrid architecture. The goal of this phase is to ensure that on-prem architecture works with the cloud and begin to leverage cloud for selected workload. And phase 2 this is where we build full data center capabilities in GCP by replicating existing infrastructure architecture. The goal of this phase is to build a complete set of the data center capability in cloud, so any backend support from on-prem is no longer needed. And then obviously, lastly, phase 3 is where we migrate on-prem customers and data to GCP and retire the data center. One thing that we noticed that is not all customers will go through the complete cloud migration journey. Rather, we commonly adopt the hybrid architecture. Due to this reason, we selected our lessons and learned from our customers who are currently in phase 1 and 2 for today. While we are executing our migration approach, we identified and selected 5 common topics that we learned from our customers for our today's session. First, lift and shift and lift and what. We'll discuss around the beauty of the lift and shift, and then the thrill of transform. There are many shiny objects and topics in the cloud, and we wanted to share a few examples around how we address them. Second, data center meets the cloud. One of the key benefits of adopting cloud is managed services to reduce the operation of infrastructure. For example, only specific versions of the open source may get supported as part of the managed services, and we'll discuss that. Discoveries and dependency. Our lessons learned from our discovery process around what are the downstream dependencies, how are we going to approach that. Deployment strategy. We'll discuss around short-term and long-term strategy around automation and how we are deploying infrastructure. To automate or not to automate is the kind of key question around that. Finally, the testing approach. Testing approach between hybrid and full stack. The decision on testing approach due to service interdependency. Test in a hybrid mode or doing an individual unit testing and putting together for full integration testing. That being said, I'll pass the baton to Swati for additional details for each topic for our lessons.
Hey, thank you, Dillon. All right. Hi, everyone. Nice to meet you. My name is Swati Lyengar. I'm a strategic cloud engineer at Google. So I'm going to talk about aspiration versus reality. So to start out with, lift and shift can mean many different things to many different people and organizations. For example, lift and shift can be taking everything that you have in your on-premise and plopping it right into the cloud. Lift and shift can mean taking what you have in on-premises and taking advantage of some services in the cloud, such as the managed services that Dillon had mentioned, or some of our big data solutions. Or a lift and shift can mean taking what you have in on-premises, completely changing it and re-platforming it to take advantage of a completely new technology stack. That being said, it could be Kubernetes engine, it could be app engine, it could be managed instance groups, just depends on how you want to move your technology stack. So there's a lot of different options here, and it can have many different meanings. That being said, how do you decide which approach to take when you're going through a lift and shift? You may look at your existing on-premise stack and see how many different moving parts there are. Maybe you have 80 or hundreds of microservices, and so there's a lot of different moving parts in how you're implemented today. And then you take a look at your application stack, how complex it is, how many different technologies is it using today and on premises, and how will that translate to the cloud? Are your applications ready? And then you gauge how much uncertainty there is. Are you moving 1 to 2 applications where you have a really good understanding of what the entire stack looks like and how that'll look in the cloud? Or are you dealing with hundreds of services? You may have some legacy stuff sitting in the application stack, and you're not quite sure what that's going to look like at the end of the day. The other input to consider is timeline. Do you have a few months to do this lift and shift, or do you have a few years? And that can mean many different things. And lastly, what's your risk appetite, right? When you're making this lift and shift, how much risk do you want to take on initially, considering all these different factors, and taking a look at your technology aspirations and where you want to take your technology stack, but then also what are the business use cases and how does that map to the approach that you want to take? It could be a pure lift and shift to begin with, and then a transformation later on, or it could be taking on the whole transition all at once. All right, so let's take a look at this example application stack that our customer had. And this is just a part of the stack. So they had 60 to 80 microservices in a global mesh, and 60 to 80 per region. You're looking at a full stack, including Apache Tomcat for the front end, Redis for caching, Dataflow, Zookeeper, and MySQL for data storage, Hadoop, and much, much more. It was the entire kitchen sink. There was a lot in there. And given that there were several microservices and a very complex application stack and a lot of different moving pieces, they decided on an approach to take a pure lift and shift as much as possible. Of course, there's always differences, right? Because operating in your on-premise data center is not exactly the same as operating in the cloud. You're moving to software-defined networking versus having hardware networking. You're looking at other differences, such as the way your access controls work and how the managed services work. So there will be some differences still. The pure lift and shift was what this customer journey started with. So the data center meeting the cloud. What does this mean? What does this look like when you start this transformation in this journey? So to start with, there's a few different things to think about. For example, when you're moving to a managed service, it's beautiful, right? With the click of a button, you get backups. You can, in the case of Cloud SQL, easily configure read replicas. You can go ahead and what else? Operate in multiple zones, have your data be held in multiple zones for higher availability, and you have SLAs, and someone's managing the service for you. It's beautiful. It comes with all the bells and whistles. But at the same time, you need to evaluate how you're using that software in your on-premises today, and how is that going to fit into this managed service? There may be a few differences. For one, there could be differences in terms of maybe how much data you're holding in one instance in on-premises, and differences in what that data that can be held, the maximum amount of data that can be held in an instance in the managed service. There could be differences in terms of how you're accessing the service, in terms of how you can access it as a managed service. So a lot of things to think about when deciding your approach. What else does it mean? So in your on-premise environment, it may have evolved over time, where you had a number of things. Maybe for logging and monitoring, you have your own in-house solutions. You may be running various other solutions like CheckMK, Nagios, Splunk, Datadog, you name it. And then when you move to the cloud, you may want to kind of look at everything that you're running and how you're configured to troubleshoot in production today and on-premise, and think, okay, if I'm going to centralize my logging and my monitoring for ease of troubleshooting, what is that going to look like? How am I going to make sure that the format is the same and that all the logs that were available in my on-premise are going to be there in the centralized logging solution? So there's a large level of effort that goes into that to make sure that, aside from moving your services over, you're operationally ready. The other piece of it is to reap the benefits of some of the key features in the cloud. For example, auto-scaling of your resources and auto-healing. You may be moving to a platform that has dynamic IP addresses, right? Where if an instance becomes unhealthy, for example, in a managed instance group, let's say, the managed instance group will go ahead and delete the instance and then recreate it, but it's going to come back as a new virtual machine with a different IP address out of a specified subnet, of course. And the question is, from an operations perspective, are you ready for that? Are your troubleshooting playbooks updated to be comfortable with that? Or do you still have the need to SSH into a virtual machine to do your troubleshooting and make sure that the logs that you expect are there, that things are working as expected. So there's a lot that has to change with respect to the operations as well. And then there's the concept of pets versus cattle. How many of you ever heard this term before, pets versus cattle? So you have your pets, right? Your pets at home. You take care of them. You love them. If something's wrong with them, you go ahead and help them feel better. And you might, put a little Band-Aid on, or maybe give them additional resources. And then there's the cattle. So when you think about cattle, each and every cattle is identical. And if you have greater workloads, you're just going to scale up the number of cattle that you have. So that's a philosophy a difference. And of course, you can have either one in the cloud. You can bring pets or unique instances over into the cloud where, let's say, each individual VM has its own configuration, and you need to keep it alive and run with only that VM and not have it be automatically deleted. You could do that with the technology, such as individual VMs or unmanaged instance groups. But you may want to take advantage of some of the auto-healing and auto-scaling that we had talked about earlier, and then take the cattle approach to take advantage of some platforms, like, for example, managed instance groups, or where it could be scaling up your pods in Kubernetes engine. So it's a little bit of a question of what do your applications look like today? How are you operationally addressing the need for additional VMs or resources? And how can you support that in GCP or in the cloud? So in addition to that, there's a mapping of people and processes, of course. Is everyone comfortable with supporting everything in production in the cloud? And looking at your solutions for things like secrets. How are you doing your secrets management today? And how is that going to change when you move to the cloud? How are you managing your SSL certificates? And how is that going to change? And the list continues. So here's an example customer on-premise footprint that we worked with. And they have a number of different data centers in multiple regions that were globally distributed and connected via point-to-point links or VPNs. And when they moved to the cloud, the idea was to bring up adjacent data centers in GCP. So what does that look like from an architectural perspective? So here, for example, you have a shared VPC network on GCP, which allows you to have a global network. And so if the resources within your cloud or the VMs need to communicate, they can communicate for the services on the private IP space. And then they wanted to suppose you have, for the interim, some tools or applications that are still located on-premise, or perhaps some of the data is still on-premise until you complete the migration. Then in that case, we set up dedicated interconnects between the adjacent regions at about 10 gigabits per second. So that's what the overall foundation looked like, and forgot to mention that with the shared VPC, the benefit there is all your resources can sit on the same network, but each of the services that are in the resources can sit in their own projects, and the access controls can be controlled at the project level while they still leverage the same network, which is beautiful. Okay, so we kind of talked about the horizontal architecture. Now let's talk about our discovery period for looking at these applications and services vertically. So here we wanted to take a holistic approach. And we learned early on that in order to take a holistic approach, we actually wanted to lay the foundation, as we did, and then also do a deep dive in every single application, or at least the significant ones. So we did this for about 45 or so applications vertically, asking questions such as, what's the function of the service at a basic level? Who are the consumers? Where are they located? So that way we can make sure that we are able to facilitate the connectivity. For example, Are the services communicating internally? Are they external consumers? Are they on premises with the customer? Are they within the same region? Are they globally located? So there's a lot of variations here, and then it also helped us understand when we would test eventually what that would look like. And then the other question was, what are the downstream dependencies from here? Who needs to talk to what downstream? And that way, from a networking perspective, we could make sure that it was set up to enable that as well. And then looking at the data layer, what do the backends look like today? And on premises, are they shared? Should they be shared when they move to the cloud? Or are they actually using completely different tables, and it would be okay to split them up and put the individual data instances with the individual services? So a lot of questions there, and other questions such as, does the data need to be directly accessible? Will it be accessed from on-prem? And additionally speaking, are there any specific security requirements? Because you may not discover them when looking at the entire architecture, but when doing a deep dive on the service, you come across some of these use cases. Like perhaps you have services communicating internally, and they're using HTTPS. And the other question is, at the deepest level, how are your health checks on your services working today? How do you identify when a service is unhealthy? Are you just looking at the HTTP response code? Are you looking for that plus a string? How does that work in GCP? Do your health checks in GCP work exactly the same way? So these are just an example or a subset of the questions that we looked at for each of the services to make sure that we recognized what was unknown early on and identified it so that way we can look at it. So other results of the discovery, what came out of it? So after going through this deep dive discovery, we actually fed the results back into the overall architecture and adjusted our architecture accordingly. Developed criteria for determining on a per-service basis which load balancer to use, for example, because there are a few different flavors within the platform. Determining how we're going to do DNS resolution during this split brain period. Figuring out other things such as how are we going to do our secrets management? How are we going to split up our data instances for each of the services? Are we going to put one service in a project? Is this currently shared data going to be split up into two? So we went from there, and one of the most important things that we came up with was a blueprint. A blueprint for if you are going to lift and shift application Y per this customer's requirements and their architecture and the individual application's requirements, what does that look like? Right? What's the criteria and what are all the decisions that we need to make when we're doing that lift and shift? So we came up with a comprehensive blueprint that we could follow to really scale when we're working with tens and 50 to 70 or so microservices, which was really key. So that way when they're lifted and shifted consistently. Other things that we looked at was we took their on-premise load balancer and did a deep dive and analysis on the features and capabilities there that were being used today to see how those would map over to capabilities in the cloud. And then we also looked at how individual teams would access the applications and how we would provision that. And the biggest piece that came out of this was the known unknown. So you have the unknown unknown, which is kind of like this nebulous thing, which is like this horrible feeling. But at least at the end of this, we had surfaced a number of known unknowns that then we could take and tackle and solution for, so that way we didn't have surprises later on. So that was a key result that really came out of this. And now let's move to deployment strategy. Now that we talked about lifting and shifting the individual applications. So there's a couple options here, right? When you're going to deploy into the cloud, you can either take everything that you have, spin up some VMs, spin up the platform, move your data over, move your image over, kind of get things going, and you're on your way, right? You can start testing and then get to production. The other option, though, the other option there is to automate it, right? With a lot of additional benefits, such as if you automate, in this scenario, there was multiple data centers, and we wanted to deploy consistently across each of the data centers. So by automating it and taking an automated approach with Terraform, we could consistently do that across 4 different data centers. So what might be some initial investment in spending the time to code resulted in longer-term speed and consistency and simplicity. And then also, if there was ever an emergency scenario and you needed to do a redeploy, you could go ahead and do the redeploy because you have the code there. You're not worried about sitting there and spinning up everything individually. So this approach nicely lent itself to multi-data center deployments, and that's the approach that we took. Okay. So now the testing approach. The big question in testing in this scenario was there was everything on premises. There was a global mesh of services, each of which were being deployed in every single region for the most part. The question is, do we test in a hybrid mode, meaning that we bring up one service and then do integration testing with the other services in on-premise to verify that it's working as expected? Or do we go ahead and come up with a full stack in GCP and then do our testing? Sorry. So by taking one service and bringing it up and testing with on-prem, that required a few different things. One is reconfiguring the INT environment on-premise. So we're polluting that environment. And the second downfall there is that you're actually not testing what's going to go in production. You're testing a different configuration than what will actually be deployed at the end of the day. So you may miss things in terms of what's not really working together from an integration perspective. So for those reasons, excuse me, we took the approach of actually testing, doing development in parallel, bringing up each of the services, doing unit testing, and then going ahead and testing in full stack, because at the end of the day, that is what will be deployed in production. And you have a clear entrance and exit criteria and can know, yeah, we should be good to go. This will be working when we get to production. Now we wanted to talk about the path forward. So after going through all of that, what came out of this? Some new guiding principles. The first being lift and shift. It's really critical to have a discussion early on and define and make sure everyone is on the same page as far as what a lift and shift means to them. Is it the lift and shift in the purest form, lift and shift with some transformation, a complete replatform, a lift and shift and then a transform? What does it mean? And then as you're going through your migration process, when you come to a decision, look back and say, oh, are you staying true to that? Or maybe you need a pivot on that initial decision. And really kind of writing that down and taking a look at it every now and then. The other is managed service preferred, right? You get all the beautiful bells and whistles when you're using a managed service. So really that's a nice way to go as long as your application will fit in it, right? In order for you to use a managed service, if you want to drive the shiny car, your application needs to fit in it. So it's just verifying that you meet that criteria. And the other is to take a holistic approach. So think about the architecture at a horizontal level, but then also do the diligence to do the vertical deep dive, so that way you can foresee what the known unknown are and discover anything legacy that's sitting there that you may need to do deeper investigation on. And the fourth, as far as deployment strategy is, especially when you're dealing with a complex environment with multiple data centers, and if you want a way to easily redeploy an emergency scenario, spend the time and automate to move faster over time. So it's automate to move fast. And then as far as the testing approach, it's full stack wherever possible, or whatever is going to look closest to your production environment. And in this case, that was full stack testing, as opposed to hybrid testing. Great. And I'm going to call my colleague, Dillon, back up here. And this is a large part of the team that was working on this migration project. It was an entire team, and honestly, there's many more people too. We couldn't fit everyone on this slide, and it's really a big team effort. There's a lot of moving parts and a lot of expertise needed to lift and shift the customer.